Would you like to know how to make collisions for a top-down game, where you might be able to turn something like this into something that looks like this? Well, keep watching and I'll show you how. G'day gamers. In this tutorial, I'm going to show you how to do collisions for a top-down game. Now by top-down, I mean we can move left, right, up, down, and we're not affected by gravity. Essentially, it's the camera above the player at some sort of angle, and we can move around like a bird's eye view. So I've created a new drag and drop project. I'm just going to start by changing my view to custom order so that I get a view that's not set at alphabetical order. That's just up to personal preference. Now the first thing I want to do is create a player, but we'll need a sprite to represent what the player looks like. So right click on sprites, go to create and go down to sprite. And let's name this S_player. Now I don't want this size, so click on the size and we'll change it to 16 and just tab to 16, press apply. And let's edit that and set it as a color. I'm just going to choose a blue color and select the fill tool and then fill that in. Lastly, we want to center the origin, and the origin is the center of the sprite. So we can just use the drop down box and set it at middle center. Let's close that down. Now we need an object to represent our sprite in the room. So right click on objects, go to create and just go to object. Let's call this O_player. So the O stands for object, whereas the S up here stands for sprites. That's just a naming convention that helps us identify the assets. So we can assign this sprite to the player and we can just move this up here. Now I'm going to create an event. And an event is basically a when action for the player. You have various events that will enable things to happen at certain times. And when we create an event, for example, a step event, we then set actions in that event and they will run when the event occurs. Now a step event happens 60 times a second. So the code in here will run 60 times a second. And what I want to do is capture the movement for our player. So if we type over here key, we can see the mouse and keyboard movement. And I'm just going to have one that says if key is down, which means that whatever we set here, and it's going to be the movement. So I want to use the A key to move left rather than the arrow keys. So I can go to A, and that means when this key is being pressed, we want to do something. And in this case, I'm going to set a variable. I'm just going to call it left. And we'll assign the value to that variable of 1. So when A is being pressed, left will equal 1. Now this will be useful later when we actually calculate the movement of the player. But for now, let's just capture all the keys. So I'm going to take a copy and a paste of that and ensure it's dragged under this one. And we're going to change it from A to D. And this will be for the right key. Now I'm going to paste it again. And this time I'm going to capture the W. So you can even just type it in here. And W is for up. So we're capturing the up press. And click on this, click paste again. And this time we want to capture the S key. Now make sure these are in capitals. And if that's down, we want to capture down. So every time a key is pressed, we're setting this variable to 1. Now what can happen is the step event can get quite lengthy. So our get input here is quite long. So instead of having this represented in the step event, I'm going to move this to a function. And that way we can call the function when we want to get the input. So over here under scripts, I'm going to right click and go to create and create a script. And scripts can be used to hold functions. So we want to hold the function of get_input. Now we can have multiple functions per script, but I'm going to name the script this, and I'm going to have just one function in this script. So back at the player, we want to take all of this. So I can click the bottom, click the top, and press Control X to cut it out. Go back to our get input and paste it in. Now you notice that this line indicates that this code is not connected to this function. This indicates that it runs after that function runs. If we want this code to be part of the function, we need to drag it to this side. So select the bottom, select the code just below the function call, and I'm going to drag that over here. And now all of that code is part of the get input function. So back in the player, we've lost our code, but we can call a function or a script. You can do it as a function call, but because we are doing one function per script, we can just execute the script, and therefore we can just select it rather than having to type it in. So we're just going to execute that script, and that will be just like we're running it in the player here. Now, if we look at get input, you'll notice that where we're setting these values, we're never setting them back to 0. So they're always going to be equal to 1. So we also need to ensure that when they're not being pressed, they're set to 0. And we can do that a few ways. We could have an else here where we set them to 0, or we could actually have another script that does it for us. And we'll just call this reset variables. So all we want to do here is reset our left to 0, our right to 0, our up and our down. So now we have that function. We can go back to our player and we can drag across another execute script. And this time we'll just reset those variables before we go and get them. So every step they're being reset to 0. And if we're pressing the keys, they're being set again. Now I want to use those variables to allow the player to move, but we need to calculate the movement of where we're going to go. So capturing this movement will allow us to move our player. Let's go have a look at a room, and a room is basically what you'll see when you run the game. You could think of it as a level. Now I'm going to change the size of the room initially, and down here is the room settings. I'm going to set the width of the room to be 360 and the height of the room to be 240. So you can use the middle mouse to scroll around and control and wheel mouse to zoom in. And now that we've set our room, I'm going to set up a camera which will enable our room to scale, which means it'll be bigger when we run the game. So just under viewports and cameras, let's enable a viewport. Go to our viewport 0. We'll enable this and make it visible. And our camera properties, as you can see initially, our camera is really large. So we need to change it to be the same as our room here. So 360 by 240. You can click this up button to bring it back in the middle. Now that our camera's set, the viewport enables us to scale the game up. So I want to make this 3 times what our camera view is. 3 times 360 is 1080. 3 times 240 is 720. So I'm just going to drag the player across and put them in the room. Make sure you're dragging the object of the player. Now you'll notice with the player, there are some coordinates here. There's an X and a Y position. If we move to the right, the X position gets larger. If we move to the left, the X position gets smaller all the way down to 0. Now the same with the Y. If we move down though, the Y gets bigger. And if we move up, the Y gets smaller all the way to the top left position of 0, 0. So we can use that information to move our player to the right, left, up or down based on what the user is pressing. So after we've captured our input, let's calculate that movement for the player, and we can do so in a script. So right click on scripts, go to create and go to script, and we'll type in calc_movement. Now let's just make this bigger. And here we'll be able to calculate the movement of the player. Now, if you remember, if we're pressing right, then the right variable is set to 1. If we're pressing left, left is set to 1. Now I'm going to go and drag across the declare temp code block. And I'm going to set a temporary variable called _hmove. Now I like to use underscore to indicate that this is just a temporary variable. It just means at the end of this function, it actually gets deleted. So hmove will hold the value of our horizontal movement. And we can set it to right minus left. And what that means is if we're pressing right, then this becomes 1 minus 0. So hmove is 1. If we're pressing left, then this is 0 minus 1. So hmove is minus 1. And if we're pressing both or pressing none, the value of hmove is 0. So it's just a tricky way to allow us to set some horizontal movement based on what we're pressing. Now we can use a similar thing for our vertical movement. And this time we have _v move. And we're going to set it to down minus up. And what that means is when we're pressing down, v move is going to be 1 minus 0. So it's going to be 1. And for Gamemaker, if we have a vertical movement of 1, it means we're moving down the screen. Whereas if we're pressing up, the value becomes -1, which means we're moving up the screen. So that's how we're going to determine our vertical and our horizontal movement. So if one of these is being pressed, then we want to move the player. So I'm going to go over to an if expression code block, drag this across, and we're going to ask a question. We're going to say if h move is not equal to 0 or v move is not equal to 0. So this symbol of an exclamation mark and an equals means not. So we're asking if these two are not equal to 0. And we're using an or to say if any of these are true, then we'll run the condition. Now, if these are true, then we want to calculate which direction we need to move. So what I want to do is get the direction that we're trying to move to. So I'm going to go over to a function call, drag it to this side so that it runs if this is true. And we're going to look at a function called point_direction. And point direction will take an x and a y, and it will give you the direction to another x and y. So we can use that with our h move and our v move to calculate the direction we're trying to move to. And we can do that by saying, imagine our starting point is 0, 0, and we're trying to move to h move and v move. So if we're starting at 0, 0, and these are going to be a 1 or a -1, this will give us the direction the way that we're moving. And let's store that in a temporary variable. And I'm just going to call that _dir. So once again, underscore represent a temporary variable. We're not going to keep this at the end. So now we have the direction we want to move. We can calculate how far we should move based on our player's walk speed. So let's just go back to the player and we'll just add a create event and we'll just add a assign variable code block and let's set up a walk speed variable. And we'll just set it to 2. So that's how far the player is going to walk per step. So back in our calc movement, let's do a function call. And we need to calculate the distance we need to move along the x and the distance we need to move along the y to move in this direction. So if the direction is this way, how far are we moving on the x? How far are we moving on the y to get to the point we need to get to? And we can use another function called length _x. And what that takes in is a length and a direction. So our length is going to be our walk speed and our direction is going to be our _dir. And this length x will calculate the distance along the x that we need to travel to get to this point. So in saying that, we can copy and paste that and we can change this to length y and that will calculate the y components. So now that we know the length of the x and length of the y, we just want to store them back into this h move and v move so we can use those variables. So our target's going to be h move and we'll store that as a temporary, and our target's going to be v move and we'll store that as a temp as well. So h move is the distance we need to move horizontally and v move is the distance we need to move vertically. So knowing that our h move is our horizontal movement, let's just set the player's x position to that h move value relative, which means we're adding it on to the player's x position. And we can do the same thing for the y. Let's look at the y coordinate and add on the v move. So now what we can do is go back to the player and we'll ensure that we run that calc movement script. So execute script and we'll select the calc movement. So let's test that out and we can do so by up here pressing run or pressing F5. And we find our player moves. So let's add some solid objects that the player can collide with. So right click on sprites, go to create, select sprite, and I'm going to call this s_solid. Go to edit, and let's set it to a red color. And I'm going to change the alpha to a lower value. Select the fill and fill that in. Now you can leave the origin there, but I'm going to change the size once again to 16 by 16. Let's close that down. Now we can go and create an object for that solid to represent it in the room. So go to objects, type O_solid, and let's assign that sprite to the object. Great, we can close that down. We don't need to do anything else with that, but we can go to our room, and I'm going to start adding those solid objects here. So let's make a new layer that they can sit on, and I'll just call this collisions. And I'm just going to change the grid for the collisions layer to be 16 by 16. So ensure you're selecting the O_solid object, and if you hold down Alt, you can actually start to drop in the object. So what you want to do is place one and then grab it and drag it out. You can drop individual ones around, but it's a bit of a waste of resources to do that when you could just drag these out. So undo that. And we'll just place more here and just build up a wall around the outside that the player can move around in. So let's add some more down here. And just something in the middle there for the player to walk into. We'll have something here as well. And that should do. So if we run the game now, we'll find that we have no way of getting stopped when we touch those solid objects. So the player just goes straight through them. So we need to set up a collision that stops us when we touch them. So back in our workspace, I'm going to go back to our player. So let's set up another event. And this time it's a collision event with the solid object. Now this code will run when we make contact with this solid. So if you remember, we are calculating our movement and we are instantly moving to where we want to go. At no point are we looking to see if we're going to collide with something. We are just moving there. So we might move to a position and then find we're in a wall. And then what will happen is this will run. This collision check will run. And it's in here that we need to then move back to our position that we were in, and maybe we'll move as far as we can to the wall before we run into a collision again. So let's make another script, and I'm going to call it collision. And what we can do is move that with our player into here. So this script will run when we collide with a solid. And I'm doing that so that you can use this same method in other objects. You create a collision with OSolid, you place the collision script reference here, and the collision will just work for that object as well. So what are we going to do in here? What is going to happen in our collision? Well, like I mentioned, we have already moved to where we want to go. So let's go and create some temporary variables. And I'm going to call the first one _tx. And that stands for our target x. So this is where we want to move to. And we'll set it at x because that's where we currently are. Now let's set another variable called target y, and we'll just set it to y. So these are representing where we want to go. So we can comment on this and say these are our target values. Now that we've captured where we want to go, let's move back to where we were last step. We know we're in a collision now and we don't want to be. So let's go and set our current x to be our x previous. An x previous is something that can be used in a collision event or in a draw event, and it will grab the value of what x was in the previous step. So we can do the same for our y. and our y is going to be our y previous. So now we've actually moved out of the collision. We are no longer colliding with the object. And if I run this now, we'll see that we can no longer collide with these solids. And there we go. Now that seems pretty simple, but it's not that simple because it's not a great method. You can see that I can't slide along. I've actually left a little gap there between us and the wall. Sometimes you'll get a larger gap like that. It just depends on what your speed is as you're approaching. You're not moved close to the object, you're just stopped from going any closer. So it's not a great solution. You also, if I press 2 keys, I can't slide along the wall. It's kind of clunky. So that's not great. Let's go and improve on it. So how we can improve on it is we can look at our X and see where we are trying to get to compared to where we are and move 1 pixel at a time until we can no longer move. And the same for the Y. We'll look at where we want to go, we'll look at where we are, and we'll move 1 pixel at a time until we can no longer move anymore or we're at our target value. So let's get the distance between our current X and our target X because that's how far we want to move. And I'm going to store it in a temporary variable. And we're going to call it _dis_x. And the value is going to be the difference between X and target X. But it could be a negative value. But what we can do is use a function called ABS, and that will return just a positive number. So if it's a negative number, it'll just give us the positive part. There won't be any sign associated with it. So we can just have the target X minus X. So that's our distance we want to move in the X. Let's add also the distance we want to move for the Y. And that'll be the same thing. It'll be the ABS of our target Y minus our Y. So now that we know how far we want to move in our X and our Y, we can use a repeat to move a pixel at a time, testing if we're in a collision at each pixel. So we can just repeat this distance X times. So if our distance is 5, we want to repeat this 5 times for each pixel to ensure that we can move as close as we can to the wall. So what we can do is just use our object at place test, drag it to the right side, and we want to look for our solid object. And we want to move just 1 pixel, but it could be a -1. We could be moving to the left or we could be moving to the right. So we need to ensure we're testing in the right direction. And we can use another function to work out which way we're going. So if we do the sign of our target X minus our X, this will return either 1 or -1 depending if our target X is on the left or our target X is on the right. Now I need to ensure we tick relative so that it'll add it onto our X. Our Y is going to be relative at 0. And we're looking for not a collision. If we're not in a collision, well then we can move this single pixel. So we'll just take a copy of that. And if we are not in a collision, well then we want to move our X. So our X becomes either 1 or -1 relative. So we're adding or we're subtracting 1 to our X if we're not in a collision, and we're repeating that however many times we're trying to move. Now we want to do the same thing for the Y. So I'm going to take a copy of this and paste it, and then we're going to change this for Y. So this is going to be our distance Y. This is going to be our target Y minus Y. And we'll just cut that out and ensure that we place 0 there and paste it down here because we are moving in the Y. And here, this is our Y, and this is target Y minus Y. So if we want to just put a comment here, we can say that we want to move as far as we can in X, and here we want to move as far as we can in Y. So now let's test that out. Press play. And there we go. So now we can slide along the walls, and we also find that we are directly next to the object. We no longer have that small gap that we had before because we're being pushed all the way to it. And the sliding along a wall is actually really important for the game. It just makes it feel a lot better when you're playing, that you don't get stuck on walls when you're moving. So that's all I wanted to show you, is basically a movement system that you can start off with to make a top-down game. You could then go add some graphics to this, make the player fire, and you've got a nice little shooter. I have other tutorials that show you how to do some of those things, so maybe check those out. Now hang around after the Patreon credits because there's some really cool content that some of my Patreons have been producing. My Patreon supporters enabled me to put out content like this, so I want to give a huge thank you to these legendary supporters: Dylan Jackson, Fox and Ravenent, Kaiser Ho, Andy K, Emre Coes, and Tom Freaky. I also appreciate the kindness of these epic supporters as well: Sky Devil Palm, Sheldon ENTP, Salvatore Capolino, and Dan Half. And these rare supporters also enable me to continue to produce content, so thank you to them. Now, if you contribute $20 to my Patreon, you get access to my latest release, which is a Gamemaker project you can use to build your own game. I've already done the hard work and have the collisions, moving platforms, player, and enemy set up, but you can use this as a base to build your own game. It's also available to purchase directly, so look in the description for a link. Now lastly, some of these guys who are following me are starting to produce their own games, so you really should check out someone like Sky Devil Palm on Twitter. He has a really cool game made in Gamemaker called Victory Heat Rally. It's a car rally game that nods back to the 80s, so check it out. As well as that, we have Salvatore Capolino, who's released a Steam game called Eternal Dungeon. These are guys who started out in Gamemaker just like yourself and are now releasing their own games. So it's always good to start programming, you just never know where it's going to take you. So thanks for joining me, I'll talk to you in the next one.